Yeah, what's the title of the thing we're doing? Yes, you're doing a limit, but what do you, the limit I need to do? The limit as what goes to what? The limit as n goes to infinity of what? What's the general form of this? A over an, right? We need to do this. So that's going to be the limit as n goes to infinity of, what's going to happen here? Negative 1 to the what? N plus 2 times 2 to the over times x minus 1 to the plus 1 all over negative 1 to the plus 1, 2 to the n over what? N, x minus 1 to the n. So do a lot of things cancel here? What do you end up with on top? You end up with limit as n goes to infinity of what? What cancels? What's the first thing that simplifies? Negative 1 to the what? 1. To the 1, right? So then you end up with, we can actually write this as one line, right? Because everything's going to cancel. Negative 1 to the 1. And then the n, what are you going to end up with here on top? You got to be careful. Just 2 to the what? What power? 1 all over what? Are you sure? So let's just write this out. We have to be real careful here. So you end up with 2 to the n plus 1 over n plus 1 times the reciprocal, which is going to be n over 2 to the n. And then what's the last thing that's left here? We can do this one. X minus 1 to the first power. Right, exactly. So you have to be real careful in the simplification here. This is the as n goes to infinity, correct? So what does this, what happens to this right here as n goes to, we can just do this. What happens as n goes to infinity here? Well, we can clean it up a little bit, can't we? So what do we end up with here? We end up with limit as n goes to infinity of negative 1 to, well, it's negative 1, right? And then we end up with, well, I understand. We're just going to do it in pieces here. It's 2n over n plus 1. Is that correct? Like this? So as n goes to infinity, what happens here? That, I mean, it's absolute value, so the negative 1 goes away, right? So we end up with, we good so far? What happens to this as n goes to infinity? That goes to, nope, well, that, just what I circled there goes to 1, right? So what do you end up with? This is just equal to 2 times what? X minus 1, exactly. 1 over 2. How do we do on this one? What do we have to do with to this? Okay, how'd you do B, guys? Derivative right now. What do we get for the derivative? Exactly. What's the only thing that's moving here? We're taking the derivative with respect to what? X. So you're tempted to maybe like make it n plus 1 times negative 1 to the n, and then you're like, oh my god, there's triple product rule, and I don't want to do that, right? But what's the only thing you need to drop down to the front? The n, right? This goes down to the front. So what do you end up with? This goes to, you get n times negative 1 to the n plus 1, 2n, 2 to the n over n, times x minus 1 to the what? To the n minus 1. What cancels here? The n's cancel. Well, yeah, these specific n's cancel. So you end up with negative 1 times to the n plus 1, 2 to the n, times what? To the, so that's the nth term, right? So can we find the first 3 terms pretty easily now? What do we do to find the first 3 terms? What does n start at?
1.
N starts at 1, right? So when n equals 1, what do we get? Negative 1 to the 2, 2 to the 1, x minus 1 to the 0. So what's that going to be?
1.
That's just 2, right? I think it's just 2. And what happens when n equals 2? End up with negative 1 to the 3, 2 to the 2, x minus 1 to the first, right? So that's going to be negative 4 minus 1. And then you have n, oops, that didn't do it. N equals 3, like this. Negative 1 to the 4th, 2 to the 3rd, x minus 1 squared. So what are you going to end up with here? 8x minus 1 what? Squared. So we have the nth term, And that's what it asks us for in this one, right? It asks us for the first three non-zero terms and the general term. How do we do there? Do you have to write it out? I mean, we could just say, so is this an acceptable way to state the answer? What do you think? It asks us to find the terms, right? Did we find them? I think we found them. Let's see how it matches in the first sentence. What's the most important thing it tells us? It tells us it's a what? It tells us it's a geometric series. Is that super helpful? Just nod your head yes. Just say yes. Yes, it is helpful. Why is it helpful to know that this is a geometric series if we're looking for where it converges?
Because then we need this test.
And when you know it's a geometric series, the definition is going to have it's going to have a common ratio. So we have our common ratio right there. Yay, we have our common ratio. Excellent. We have f prime of x written as something plus something plus something, and it's an infinite geometric series, right? So if you want to add these all up, what's the sum of an infinite geometric series? The first term, a over 1 minus the r. So what's it doing right here? It's telling you that it wants a function. Look, find the function f prime to which the series converges, right? So they're calling the sum. This right here is the sum of all the pieces right here. And what does it tell you to call that function? F prime. It says right here, find the function f prime to which the series converges. So what is it converging to? It's converging to this right here. But then what's it asking you to do once you get that? Use this function to find f. So if you have f prime, how do you find f? You integrate, right? So you take this function and you integrate it, and you end up with this right here. What's the last thing you need to solve for, though?